In this clip, we're going to talk about axioms of probability. Let's review some basic concepts. Alright, so when we talk about probability theory, we usually have we have an experiment, a random experiment, and from this random experiment we get an outcome. An outcome is a member of this set sample space. Okay, so sample space is a set of all possible outcomes. For example, if we have our experiment is flipping two coins, so the sample space S is equal to okay, you might get two heads, the first head and then tail, and a head, or getting both tails. So this is the sample space for this experiment. If you have 5 people running a race, and our outcome is the order that these people finish the race, assume that there's no tie, then the sample space S is a set of all permutation set of P, where P is permutation of this set A, B, C, D, E. Okay, so the size in this case is size of S, as we have counted before, so the size of S is 5 factorial. Okay, if you have a sample space can be so it's just a set, so it can be continuous. Okay, so for example, if you measure the times in seconds used to transmit a 1 megabyte file, so so set S sample space is a set of all integer x, no, real number x, such that x is between 0 x to infinity, right? So it's a set of non-negative real numbers. Okay, all right, so from a sample space we have an event. So suppose we have a set of all possible outcome S. An event is just a subset of the sample space, and we want to talk about the probability of an event. So we have this notation. Okay, so we want to say that for each event E, we can talk about under in the sample space S, there exists a probability of E, right? And we denote this by P of E. And previously we talk about P through a simple model. Okay, so like we have a bag and then we pick an object of a bag, right? And we in this segment we want to talk about more about the axiomatic treatment of P. Okay, so we're not gonna say that P you have a bag or anything, because our experiment will get more and more complex, and also there's some when the sample space is continuous, it's hard to think about how many things that you're gonna pick, right? All right, so so we're gonna just discard that previous simple model and treat P as just a function. Okay, and we assume that this function P satisfies the following 3 axioms, and these axioms, when after you see it, is basically something that correspond to our notion of probabilities that we have used before. Okay, So the first axiom say that the probability of any event should be from shouldn't be negative numbers, right? And should be at most 1. Okay, so probability is a number between 0 and 1. The second axiom says that the probability of the sample space is 1. Okay, so it means that the probability that you're gonna get some outcome from this set, okay, is 1. So something is gonna happen for sure because you do some random experiment. Okay, so that's what it say. So basically the maximum, so you said you know that any event, the probability is from 0 to 1, and S is the and it reached 1 at the sample space. Okay, and the last one is basically this is like it might look a little bit complicated, but if you think about this is this only say, so if you have 2 events, so if you think about 2 events, if you have 2 disjoint events or mutually exclusive events, it's the same thing. And you say that the probability of the union of this event is the sum of the probabilities, and this is true. So for axiom 3, it talks about this for a countable sequence of disjoint events. So not only 2 events, but you have like many, you can have many events, countable sequence of disjoint events. So you can have a lot, but it has to be countable. Okay. All right. So okay. So if you have, so this is a set S. If you have, say, E1, E2, E3, this axiom says that the probability of the union of these 3 events, if they are disjoint, or sometimes we call it mutually exclusive, okay, should be equals to the sum of the probability here. Okay. All right, and we also have the notations from the set theory and everything from the previous lectures. So let's have a quick review. So if you have A and B events, okay, so this is S, and you have 2 events. So in general, they might intersect, right? And then you have A union B, which is like the union of the 2 events. You have A intersection B, and we're gonna write it like this after later on, because this is shorter, and for the union we have this union symbol. For the intersection we just ignore it, we just write AB. Okay, and this is a complement. This is complement of A, so you have this is S, and you have A, and the complement of A is this. Okay, and you have this A given B. So by definition, this is AB, probability of AB over probability of B, and this only defined when B, probability of B is greater than 0. Okay, and we because A and B are both sets, we can use this symbol. We can say that A is a subset of B. Okay, so these are a quick review from of the notations. All right. With these axioms, we can prove many interesting facts. So we have the first example. So we're going to show that the probability of an event A equals 1 minus the probability of the complement of A. So this say that the probability that some event would occur equals 1 minus the probability that it doesn't occur. Okay. So to prove this, we gonna start with some simple fact. Okay, so A complement A, so we know that A union A complement equals this sample space. Okay, we know that, and we also know that A and A complement intersect with A complement. These two sets are disjoint. So we know that from the third axioms, we know that the probability of A union A complement, this equals, because they are disjoint event from this, so you know that this probability of A plus probability of A complement. And anyway, so this, because the sets are equal, so this P of S, and from, so this part is from axiom 3, and then, but we know that probability of S equals 1. This is from axiom 2. Okay, and you can solve this, right? This 1 equals this, and yeah, so you get this equations. Okay, now if you want to prove that if A is a subset of B, then probability of A is not greater than the probability of B. Okay, how are we going to prove that? Okay, so if you need more time, you can just pause the video. Okay. Alright, so let me give you the solutions. So basically, if you want to use the axiom, then you better you should try to relate this set A and B, right? So let's draw some pictures. So you have set B, and A is a subset of B. Okay, you want to show that the probability of A is at most the probability of B, right? Okay, from this we can say we need to somehow argue that this is less than that, right? So we can just start by notice that probability of A, probability of, okay, so we start by saying that B equals what? A union B minus A, right? This is A, and this is B minus A. Okay, and note that they are disjoint, right? This set and that set are disjoint. So we know that the probability of A union B minus A from the third axiom again equals the probability of A plus probability of B minus A, right? And this is this equal to, go on this side, this is probability of B, right? Because this is B, so it's the same thing. However, we know that from the, so from this step is axiom, the third axiom, but we know that from the first axiom that P probability of any event is at least 0. Okay, so now from this one and this one, you can conclude that PA is at most PB, right? Because this term is at least 0, so you can you do something, you can show that PB, from that, using basic algebra, you can get this. Okay, all right, so my last the question of this segment is this. So from the axioms, can you prove this? Okay, can you prove that the probability of the union of the event equal the sum of the probability of the event minus the probability that they both occur? Okay, and with this we can answer the question from the previous clips that when what's the condition where this term, the union, equals the sum of the probability A and B without this term. Okay, that's when this term equals to 0, right? So that's the answer for the previous questions. But the question of this segment is to prove this. All right. So see you in the next clips.